Hello, ladies and gentlemen, and welcome to our pitch event here on the industry stage at the Formnext 2023. I don't know about you, but when I go to the leading trade fair of an industry, I naturally want to see the latest and greatest innovation by the major industry leaders. I also want to see and explore what their competitors have to offer. And sometimes, if necessary, I also want to find out if there are any solutions to the challenges I face in my own company. One more thing I want to see at a leading trade fair is, of course, a glimpse into the future. But I don't mean the future that is being shaped by the big companies, but rather a future that is full of ideas that have not yet been seen, full of ideas that may shake up the market leaders a little bit, or probably ideas that will solve completely new challenges, and finally, of course, ideas that are fascinating and possibly unbelievable. The problem with this aspect is that the young companies that give us a glimpse into that future usually don't have the means to present their information to us at the leading trade fair. However, because Formnext is no ordinary leading trade fair and has always placed great value in not only presenting new and fresh ideas, but also supporting them, startups have been given the opportunity of presenting their ideas to this wide audience from the very, very beginning. In my opinion, and what is perhaps the most important pitch event or pitch competition in additive manufacturing, startups have the opportunity to present themselves to a wide audience, not only here, but also to you at the live stream. And in addition, they can take advantage of a free stand and corresponding marketing in the media by winning the competition. This year, for the first time, we even have two so-called startup areas where you have the opportunity to enjoy innovations of the future in a very concentrated and condensed form. In addition to the winners of the Pitchnext event, Formnext also allows exhibitors from the Federal Ministry for Economic Affairs and Climate Action to take part at this Pitchnext event. So you, as a spectator, can really look forward to an exciting mix and very interesting topics today. The conditions for the participation are, of course, clearly defined. So a startup must not be older than 5 years. They are not allowed to have an annual turnover that is higher than 10 million euros. And of course, last but not least, they should not be involved in a company with a turnover of more than 10 million euros. This clearly outlines the definition of a startup for this Pitchnext event. To make a startup challenge like this possible, you not only need a major partner facilitating like Formnext, but also sponsors who support the whole thing. We would, of course, like to thank you, these sponsors, most sincerely. The first partner is no longer a startup for sure in its field, but rather one of the most important players in our industry when it comes to venture capital in the field of additive manufacturing. Not only does AM Ventures contribute to the selection of the winner, it also continues to develop the Startup Challenge together with Formnext. And in addition, AM Ventures presents the AM Ventures Impact Award, an additional prize that emphasizes the idea of sustainability at this event. So thank you very much, AM Ventures, for the partnership. VoxelJet, and you will see that later, is a long sponsor for us to, naturally, of course, the 3D printed prizes here at Formnext. Thank you very much, VoxelJet. They are really looking nicer each and every year. Last but not least, thanks to one of the leading media in our industry, 3dprintingindustry.com, the startups have the opportunity to draw additional attention to themselves with an article on the website. Many thanks for this too. So one of the most difficult phases at the Startup Challenge is certainly the selection of the winners. Because for this we need absolute experts in the field of additive manufacturing, who are able not only to evaluate the innovation, but also the whole startup as such. We are delighted that we have once again been able to work with absolutely top expert, and let me introduce the jury for this event. First of all, we have Dr. Christian Arnst, CEO of Fraunhofer Center for Network Adaptive Production and Professor for Manufacturing Technologies and Machine Tools at the FH Aachen University of Applied Science. Then we have Stefanie Brickwede, Head of Additive Manufacturing at Deutsche Bahn and at the same time Managing Director of Mobility Goes Additive. Then we have Arno Held, Managing Partner of AM Ventures. Then Dr. Peter Meyer, Head of Chair of Materials Engineering of Additive Manufacturing at the Technical University of Munich. And Alexander Oster, Director Additive Manufacturing at Autodesk. And last but not least, Michael Patch, Editor-in-Chief, 3dprintingindustry.com. Many thanks to our judges, as every year the decision was surely not easy. Now, let's get into the pitch event. A total of 16 startups from the fields of materials and applications, software and hardware await you. Each startup will have 3.5 minutes to present itself and 1.5 minutes to answer your questions, of course, yours from the audience as well. So use our tool Slido, please, because it allows you to put the question live on stage in practically no time at all and without having to register extra. Make as much use as possible from Slido and answer as many questions as possible to make this Pitchnext event as interactive as possible. So we will take a short break between each and every section in order that you can concentrate fully on the next topic. The whole Pitchnext event will conclude at 4 p.m. with an exciting panel on finance, funding and startup culture with absolute top experts in this field. So don't miss the opportunity to gain insights into the current status of the startup scene in our industry. And afterwards, we will, of course, award the prizes to the winners of the Pitchnext event as well as the AM Ventures Impact Award. So we will start today with the materials and application section. And as promised to all of you, we have a number of highlights to offer, and we would like to start with one of them right away. Especially if there's a high dependency on raw material, which is nearly all the time the case in our applications, it's extremely important to find ways not only to recycle this raw material, but also to be able to reuse it for its original purpose. And not just under normal conditions in this case, but also in a vacuum and at minus 60 degrees. Can't you imagine? I couldn't either. But how exactly this works is now explained to us by Adrian Kukowka, CEO from Progresja New Materials. Adrian, stage is yours. Applause for Adrian. Welcome.
Thank you. Good afternoon, everyone. My name is Adrian Kukowka. I represent Polish startup Progresja New Materials. And today I would like to show you our idea, our technology of European titanium recycling hubs. Why we are all here and why is Formnext growing and additive manufacturing growing? Because it is moving from research and development to proven manufacturing method used in automotive, aerospace industry, medical industries, and many others. And the development of additive manufacturing technologies drives the surge in need for materials. And among metals, titanium leads the pack with the most usage, and European Union leads in the market of feedstock production. But as a leader, we have a big responsibility and challenge to overcome when it comes to titanium. We have no titanium deposits in Europe, and we are forced to import it from China, Russia, and the USA in majority. It drives the price up not only because of high energy consumption, but also because of the transportation costs. And with low recycling input rate and with dependence on import from outside of Europe, our key industrial sectors like aerospace and medical sectors are in geopolitical risk of break of supply chain for titanium. What is more, we have this fly to buy ratio. So in aerospace, to manufacture a part, we need to buy 10 times more of material. And 90% of this material is removed. This is very costly because we have to buy a lot of material, and after we machine it, we lose 90% of its value. And when we combine the loss of value of the material and the loss of the material by machining, we lost 95% of the value of titanium used to manufacture a part. And here comes our solution. We have developed a technology to turn scrap from machining, the oversized powder from powder atomization, and other titanium waste to powder for additive manufacturing, for laser powder bed fusion, binder jetting, and direct energy deposition. We have spent several years developing industrial scale technology to serve the biggest in the industry, for aviation industry, for powder metallurgy industry. To do that, we have gathered an interdisciplinary team from heavy industry that after successful exit from heavy industry focused on this development. And our idea is to build a network of these recycling hubs among the European Union. We have partnered with the biggest research institute of non-ferrous materials in Poland, and we have secured an over €1 million grant. We have a revenue model that is adaptable through sales of powders, sales of AM services, and sales of recycling lines to the industry. Right now, we are raising 2 rounds of funding to secure scale-up of technology, to start the production of over 40 tons of powder annually, made entirely from scrap. If you have any question, you are more than welcome, and to visit us on our booth in Hall 12.
Thank you so much, Adrian. First of all, awesome presentation. You met the time scale, that was awesome. Let me ask you a question. You mentioned that actually we have 100% dependency on titanium from other regions in the EU. Yep. Once you are in place, how much can you reduce this dependency, in your opinion?
Right now, this will still be a problem because we are aiming at additive manufacturing industry, but we believe that we will cut this dependency in half.
Very good. But is it only then belonging to additive manufacturing, or could it be a model for other industries as well, if you recycle it?
There are other more suitable technologies for other industries. Our is perfectly optimized to suit this market, additive manufacturing market. And yeah, that's our way to suit this market.
So beside being present here at Formnext, what is, beside the investment, the main thing you are looking for right now as a startup?
We are looking for industrial partners. This is also why we are here to meet with our partners from aerospace industry, for powder metallurgy, which are all here, and machine producers. So we are looking for partners to provide us with the titanium waste. We need the final user that will buy the powder and test it on their systems, because the powder is exactly the same as a commercial powder from atomization. So we need to test it and apply it for all devices from various producers. And we also are looking to cooperate with powder producers to fit in their supply chain with our machines.
Okay. They are not considered as competitors. They are rather somebody that could buy your machine in order to...
We are the missing puzzle in the powder atomization, because there is always some powder that is out of scope, and we can bring it back to scope and into the market.
Perfect. Thank you so much, Adrian. Big applause for Adrian again. Fantastic solution, in my opinion. Thank you. So, of course, as we just heard from Adrian, recycling is also of a great importance in other areas of additive manufacturing, as recycle can make a decisive contribution to a sustainable production, for example. So this is exactly what the founders of Recycling Fabrik thought. Founder and CEO of Recycling Fabrik, Rudolf Loy, explains to us what exactly they recycle and how they do it. Rudolf, stage is yours, please.
Circular economy in 3D printing. 3 years ago, I started with Jörn and Jonas, my co-founders, an unexpected journey to bring circular economy and additive manufacturing together. Due to coronavirus, we discovered a huge problem: plastic waste. Plastic waste in additive manufacturing, and nobody who is caring about this waste. But why? There's so much high quality material that is not mixed up, it's not contaminated, and it's left over from the beginning. So support structures, the first prototype you ever do of a new product, and after this, it's getting an incineration. But why? We started collecting the material from customers, from businesses, and developed a solution of circular economy in 3D printing. We have a whole granulation and processing machinery, not to recycle kilograms, to recycle tons of material. After the rework of the material, we have multiple extrusion lines to get high quality 3D printing filament that you can use again in your 3D printer. And our customers said there is no significant quality loss in the print quality. Now, we have different solutions for businesses and private customers. When you have high amounts of material and waste, you can get back your own material as recycled filament. There we are starting at 100 kilogram. When you just have a few kilograms, you can send this waste to us for free. We are taking the shipping and put the material back to the recycling circle. So the great advantage is that you have no waste disposal costs at all. You just have to fill a form on our website, tell us how much waste you have, and the rest is our business. Also, for medical or data protection compliant prototypes, parts, we have special offers to handle these parts with care. You can find us here on the Formnext in Hall 12.1 at booth 39E. We are here at Formnext to look for new cooperations, for strong partners to build our brand in whole Europe. So if you are interested in our brand, come to us and let's have a talk. Thank you for listening.
Thank you very much, Rudolf. Excellent presentation again. You talked a little bit about quality, and as far as I know, when we talk about plastics being recycled, it's always not the same quality as at the very beginning. How can you ensure that it is the same quality?
Yeah, so there are different quality marks you have. So first, the parameters of the material itself, so the diameter, the print speed maybe, you can nearly use the same default settings you are always using. So there's no difference. Mm-hmm. The other settings are the mechanical properties, the thermal stability, it's just getting lost a very little bit when you have multiple cycles of the same material. We tested this intensively with a batch of material multiple times, multiple recycling cycles, and noticed after 5 to 6 cycles the material degradation, so the loss of the properties is just 5 to 10%.
And that's okay, or?
For most of the use cases, it's totally okay.
Yeah.
And you have to notice it's always the same material, and we are always getting new waste. So the worst case, it's really not that common.
Okay, very good. So you give it back to the user, and then you get new waste and produce it on that also have only this 5 to 10% variation. Thank you so much, Rudolf. Was a pleasure to have you here. Thank you.
Bye.
So something that we can observe, particularly in additive manufacturing, is that more and more startups are not only focusing on innovation, but are also making a real contribution to improving condition in the healthcare of people with their solutions. The company Odapt has developed a solution for a disease that is far too often, in my opinion, under the radar in our society. I'm very excited to see what contribution this solution will make and look forward to the presentation of their company. Join me on stage to welcome Ivana Lobe, CEO and co-founder of Odapt. Ivana, stage is yours.
Perfect, thank you. So I'm gonna present your startup, Odapt. So we are 4 people in the team. We have Jessica and Patricia that are here based in Barcelona, and myself and Mario now based in California. So we're here today to talk to you about this problem, which is that ostomy bags suck. So for those of you that don't know, an ostomy is the surgery that is performed when there's a colon cancer, a Crohn's disease, a colitis, that consists on cutting the intestine in the affected zone, taking it out through the abdominal wall, and forming what you see in red, which is called a stoma. So we're talking about more than 15 million people in the world living with this bit of intestine here, the stoma. And because the stools are going to be going out of the stoma, people are going to be using what is known as an ostomy bag, which is what you see on the screen. This bag is composed of 2 pieces. There's the wafer in contact with the skin and the pouch, which is the one that is going to be clipping on it. After talking to more than 200 people, we realized that there were actually a lot of problems with ostomy bags, the main one being leakage. So we decided to focus on this one. So what happens here? Basically, this is what exists in the market right now, and it's this solution that people need to every single day cut and manually and simulate the exact size, the exact shape of their stoma. So not only this, it's very overwhelming, but it's kind of thought for perfect, rounded, protruding stomas, but actually most stomas don't look like this, but rather can get very complex shapes and unique. So it becomes very tricky to cut, and then it just doesn't work well and it leaks. So when we talk about leaks, it's not only a leak of saying, okay, I need to go home and get changed. It's much more than this. It means skin irritation, it means pain. So we're talking about acid gastric going directly to the skin, so it can even mean sometimes going back to the surgery room. It's actually a growing market. There's more and more of these surgeries around the world every year. So because of aging population, because of more surgeries being available worldwide, and people are kind of stuck with this problem of leakage. So this is where Odapt came. So we decided to design a solution where, as you can see here, you can see myself scanning the anatomy of a real user in one of our workshops. So just with a smartphone, we scan it, and then we're able to customize a piece that is designed specifically to the anatomy, to the requirements. And then we have this prototype that now what you see on the screen is a prototype by Alchem. So we add the silicone gel that attached to the skin, and then the user is directly able to clip the pouch on top of it and go with it. So once again, it's adapted to the stoma sizes, to any specific shape, even the contour. No? If there's a specific scar we want to be avoiding, we can do this, any color, skin tone, or any colors in general. And this is how it looks like. So the good thing about silicon is that it can be boiled and sterilized, which means it can be reusable. Because right now, the current solutions, people actually throw it every day, they put a new one, throw it again and again. And this one, we can keep reusing it. We're talking about a Class 2 medical device in Europe, which means we need to go through a clinical trial. And in terms of go-to-market strategy, we want to go directly to the consumer. They can scan it, ask for the piece, receive it at home, and also partner with hospitals. And finally, what are we looking here at Formnext? So we're looking for manufacturers to be able to do this clinical trial. We're looking for funding to fund this clinical trial and for design to automate the process. So thank you very much.
Thank you so much, Ivana, for this presentation. Let me ask you the first question that came to my mind is how was this idea born? I mean, that's really let's put it rather rare use case for additive manufacturing. How did this idea came up?
So to be honest, it was a few years ago. I was living in London, and I remember I met this 25-year-old guy, and he was really, really stressed because he just had a leak of his ostomy bag. And back then, I even remember thinking, okay, what is an ostomy bag and what is this leakage problem? And that day, I learned about the problem, and I had the opportunity at university to do a project. It started like this, and then I met Jessica, Patricia, it escalated, and now it's a 4-people project.
Great initiative, to be honest. And so you're looking for partners here. That's basically it. And for funding, how much do you need, or what are the next steps you are? Or what are there already clinical studies in place, or?
Yeah, so right now we're at this stage that we have this working prototype that we really need and want to test it with users, and have already a lot of volunteers that want to test it. We've done this starting partners with hospitals in Barcelona, with Hospital Clinic specifically, and we're willing to do these clinical trials. And for this, we need the manufacturer. As you need with medical device, you need to really simulate how it's going to be once launched in the market and replicate this. So to do this clinical trial, we definitely need fundings, and it's medical device, it's Class 2, we need tests, we need labs, and we need the test itself. So we're looking at around 500,000 euros of funding to do this.
Keep on going,
trial.
yeah.
Yes.
And how long do you think will it take to get through the clinical studies and to get it registered and certified, everything that you need to do?
So we are really looking at this year, 2024, to start all the clinical trials, and we are hoping that in 2025 it would be available in the market, hopefully.
Great. Wish you all the best.
Thank
Good
you.
luck. Thank you so much, Ivana. Ladies and gentlemen. So one advantage of additive manufacturing for sure is that you can print nearly every shape and form, whatever you can think of, and you can design it. So you open completely new areas of application with using these technologies. And in my opinion, it's get really interesting when it becomes possible to combine different materials in one printing process. And this opens up significantly more possibilities for the use of additive manufacturing. And the company AMAREA Technology, a spin-off of the Fraunhofer Institute, is doing just that. And its CEO and co-founder, Steven Weingarten, who will tell us about his idea, but more importantly, in my opinion, about the implementation. Steven, stage is yours.
Thank you for the kind introduction. Hello, everyone. It's so good to be here. Yeah, as a spin-off from the Fraunhofer Institute for Ceramic Technologies and Systems, we are founded in Dresden in February this year. AMAREA Technology is 3D printing, a system manufacturer for 3D printing devices and 3D printing materials. That's the wrong presentation, sorry. It's okay. Hello, can you hear me? This isn't my actual presentation, sorry. So, yeah. We are a system manufacturer of multi-material 3D printing devices and advanced 3D printing materials. Our modular, scalable 3D printer can combine up to 6 different materials in one print job. The technology developed over the last 8 years at Fraunhofer Institute is called multi-material jetting and works with all classes of materials. That means we can combine ceramics, metals, polymers, and composite materials. The integrated quality control and the automated parameterization of the printing process ensures a reliable manufacturing process. And future expansions modules, such as laser-based inline machining, generates more features in the future system. It doesn't work. The major, the key to success for multi-material additive manufacturing is the right material. On our position, the material combination. In the last 8 years at Fraunhofer IKTS, we developed a large number of multi-material combinations ranged from different oxide, nitride, and carbide ceramics, cemented carbides, or stainless steels, glasses, and other materials. And with this large material portfolio, it is possible to create multi-material components. And these materials have the most diverse combinations of different materials inside. I will give you a short teaser for a material combination. This is a project with the Technical University of Dresden. We built an igniting structure for aerospike engines consisting of 2 different materials with different electrical behavior. One is highly resistive, the other one is highly conductive. And we built this igniting structure, and it works in harsh environments with working temperatures up to more than 1,500 degrees. And this brings me to the call of action of my presentation. We are looking for you. Join our pilot program and become our partner. We support you and develop with you your multi-material smart products. If you need more information about our 3D printing systems or our 3D printing materials, visit us at our booth and in Hall 12.1, booth B39A. Thank you very much for your attention. Sorry, this was my presentation.
Don't be worried, Stephen. First of all, it was anyway an excellent presentation, and this makes it even more professional to deal with the fact that there was no presentation or not the right one in place. So can you, if you are allowed to, can you give us a little bit a glimpse in what different kind of applications will be feasible then with your solution?
This is, for example, some jewelry stuff, clocks, something like that, or heating structures for harsh environments, so wafer shucks, something like this.
Okay.
Or special tools. We can also print cemented carbide and can combine different cemented carbide variants to each other for different physical properties.
What is always interesting for me is look at the bigger manufacturers of machines, etc. They probably go into a similar direction. Is that sometimes a competition? How do they consider you and your startup, though?
Yeah, actually, we work on our pilot device next year, 2024. In the beginning, it will be finished, and with this we will start and.
Let's see. Okay, very good. Stephen, it was a pleasure to have you here. Good luck with your solution.
Thank you very much.
Stephen Weingart, ladies and gentlemen. I want to remind you, by the way, of Slido. If you're following the live stream, I do it all the time, by the way, and it's fantastic to see myself here on stage and, of course, the fantastic startups. So please use it because it gives me the opportunity to answer, let your questions be answered here on stage. So again, use Slido. It's worth it, I promise. So when it comes to sustainability, we often look at the actual product itself and its manufacturing process. But when it comes to the packaging in particular, reusability can be just as beneficial as the manufacturing process itself. I'm very excited about the story of Kunz packaging and what it has to do with additive manufacturing, indeed. So welcome Matthias Kunz, CNO and founder of Kunz Kunz Packaging. Matthias, stage is yours.
Thank you, ladies and gentlemen. Good evening or good afternoon. Okay, high performance packaging is often used, but in our respect, is it when it comes to liquids and when you are distributing liquids worldwide, it's already a challenge. But when it comes to dangerous goods distribution worldwide, it's even more difficult. When you are a distributor, you have a lot of requirements you have to fulfill, and they're getting more and more and stricter and stricter. And we show you here on this slide what you should have on your radar before you dispatch liquids, especially dangerous goods. What we offer here, it's a packaging which looks very ordinary, like a jerry can. But the technology is not only having a PE, which is a standard mass-produced polyethylene, it's actually a multi-layered jerry can, or a multi-layer packaging in general. But the option here is you see an orange layer, which is the EVOH, which is used very often in food packages, but it can also have the beauty to be an oxygen barrier, which expands shelf life for your curing agents, for solvents, for alcohol-based materials. And on this slide, you can also see one layer, it's called recycled HDPE. So this will be a door for the future to use recycled granular PEs. So this packaging has the potential to fulfill quotas in the European Union for the future, and this is why I want to show you this slide. Okay, these are the options we have. So we of course started with the jerry cans from 3 liter to 30 liter. We have different shapes, of course, and we bring out a new packaging, which is a round bottle family. We start here now in the European Union, and it's the same technology. 6 layers with this oxygen barrier, and we can also put ultra pure polyethylene at the inside if needed. We can also have master batches which protects the UV light from the liquid inside. So here you can see a lot of industries, they are using already the technology, but I think it's also a good idea to maybe look into the UV curing processes, whether you have an expanded shelf life in this respect. Okay, what can you expect from us? High performance packaging with the maximum safety. We have also data of CO2 footprints. We're producing this packaging in Europe. I have an experience of 25 years in hazardous substances and dangerous goods. I had a chemical company for many years, and we have an individual advice and support from selection to the right packaging, to the full change of packaging with storage. We look into the safety data sheets. We know a lot of chemicals in combination with packaging. So we can be of help here. Okay, that's it from me. And you will find us in booth B55E. Thank you.
Thank you very much, Matthias. Big applause for Matthias. Matthias, what brought you to Formnext? Where's the connection to additive manufacturing? What are you expecting here at the fair, and what is your plan?
As I said, I was in the chemical industry, and we had a chemical filling company, and I was always responsible to choose the right packaging. So customer came with a recipe, and they asked for a filling, and then I had to choose. Okay, what is the right packaging? And then I stressed a lot of packages. At that time, I was just purchasing external packages. And then I found this Coax 6 technology. And then I started 12 years ago with the idea of testing and stressing. And one of the first customers was actually from the dental industry. And they, of course, asked for UV protection. And then I understood, where is the need in this industry? And then I expanded the business. And yeah, today I help also the customers to find the right packaging, but also not only leave the customer alone with the question, what do we do with the empty plastic containers? So I also look into future recycling streams for PE. What about if it was in contact with dangerous goods? How can we clean it? And all this is yeah, now my new playground.
Very nice, very nice. So you should connect it to Recycling Fabrik then.
Yes.
That sounds
Could
like
be,
probably a good
absolutely.
connection. Thank you so much, Matthias.
Yes, thank
To
you.
have you on stage.
Thank you.
Thank you.
Thank you.
So there are many ways to enable applications in additive manufacturing, and believe it or not, there are as many challenges at the same time. At AMAREA, they have set themselves the goal of tackling these challenges together with interested companies. The clear goal is to enable customer to do additive manufacturing themselves. Today, we have the opportunity to meet one of the partners of AMAREA and hear their story. Join me on stage to say hello to Andrew. I tried to say the name correctly. Triantafilo. Is that more or less correct, Andrew? Stage is yours.
Thank you, Sven. So let's pitch why we strongly believe that AMAREA is making it easier for companies to grow with additive. We are building on a network of more than 150 AM experts along the value chain. So there are people on business, there are people on design, there are people on materials, on simulation, all down to certification. So we cover the entire route. We are impartial because we don't sell machines. We are technology agnostic because we are looking for the best solution for the customer's idea, not for the technology. We are at the forefront of technology development because quite a few of these people are still very well connected to research, to technology transfer. So we are there to really look at the very best of technology. And the other thing is we are spread across Europe, so we have people in most of the countries. We've been doing quite a lot of things in the past. For example, last year we've been printing tiramisu here at Formnext. Some of you might have tasted that. Another example is printing accordions. This accordion, Andrew is just holding it up, 80% additively printed. So it's again, for companies coming up with an idea, sitting down together with them and discuss what should you do. Our offering is twofold. We've launched a community where people can discuss, where people can exchange their knowledge, where they can engage, and where they can visit industrial technology talks, as we call them, to really discuss top-notch topics. All those people that want to go commercial, those that look for intellectual property rights, or that just want to go quicker, they can go for commercial services. We have tutors there that are ready to accompany them all down the route, as long as they want from where they come to where they want to go. There are experts. We put teams together that solve their specific challenge. If it is business, materials, again, I already told you. So teams that are specific to what the companies want to do. And these services should then, in the very end, accelerate the development of the company's product. What's next? If you have a challenge, we would be dead happy to talk to you. Come to our booth. We're ready there. We even give away 1 hour of free support to give it a kickstart. You're at Formnext.
That's where I'm in. Thank you so much, Andrew. Big applause for you. So that would have been my first question to you. What is the business model behind it? So it's a consultancy model, so we pay like daily rates? Or?
We don't love to hear we are consultants because we are really there to help people along the road. We're having this free community. It's free to sign up. It's free for people to get the first taste, to get the first inspiration. But it's then, for sure, I mean, it is a business, so we need to earn money at the end of the day. It is to sit down with the customers and discuss their individual case, and that definitely needs to be commercial. But again, community is free for people to engage and to check out options.
Awesome. Very good facilitator. Sounds very good to me. Thank you so much, Andrew. Good luck for the future. And a lot of pushing the additive manufacturing work. Would be great to see that. Thank you so much. Andrew, ladies and gentlemen. So we are pretty much on time, more or less. So you will get now a 5-minute break. This was a section of materials and applications. Please be back in 5 minutes, because then we will dig into the topic of software. Super exciting startups coming up there. See you in 5 minutes. Enjoy the highlights.